there is another trail you can do here. You can do a trail around the mount. And here is a light bulb. This one.
I left everything open, but then this part.
This is el faro del caballo sobre There are, I think that's 700
Remember that one now?
steps and stairs to reach the lighthouse. Yes, 700. And it's quite famous here, I can tell you, to get there. Here.
The question was
Google satellite image.
Web Prima services,
The plugin.
but forget about the satellite type. Okay? So what do we have here? We have the shape of the buildings. You make zoom. You know, you have polygon for each one of the buildings in San Antonio. Okay? And if you take a look at the attribute table, here you have the ID. The zoom pop is the population of the building. The valor kata is the value, the economic value in euros. The average altura is the average height of the building, not quite accurate. And the grid is another information not relevant for us. The relevant is that we have sum of the population and the economic value of the building. Okay? And now, here we have 1, 2, 3, 4, 5, 6 raster layers for 3 different horizons, 2020, 2050 up to 100, and for 6 return periods flooding events. So we can compute the risk, as we did last week on the case of Focus, that we did it by hand, but now we can do it here. So let's load the 2020, the present 100 years return period. Let's take a look at what's happening. We have some flooding there. Not too much, a bit more here, a bit more here, I think.
Okay.
I'm not sure if any flooding here in Berea. Let's change the color of the flooding. Blue. I'm going to discard the side tile. Here we have complete view of what's happening. Okay? So I need a plan. What do you suggest we can do to obtain the risk, the consequences over the population?
You can create a new value in the table, multiplying the vulnerability times or exposure times.
Okay, we are going to create in our attribute table. We are going to create a new field. We are going to call it consequences. Okay, and this field is the result of what?
exposure times
This is the same. Exposure
Yeah.
times
the
hazard.
level.
Okay.
Taking the event.
So now we know we need to create a new field for the exposure.
Exposure, probably it's already
No, it's already there.
So exposure is some point.
in the given map.
Okay.
Probably hazard is the flooding scenario.
Okay. But we don't have that in the table.
But we have the T5.
Yes. So
We can import it and convert it to a number.
Yeah.
you can convert the diff file into
value
a
in the table.
value in the table. How? I don't know how to do that.
Didn't we do that with the last T5? Like
It was a table. It was tabular.
we included it
You
in the
can
table?
convert it to polygons.
No?
No. We join the attribute table with another tabular information using one common value. But with the diff file, we haven't
Oh,
merged it.
that's right.
We have done another thing.
It wasn't a T5.
Come on, I have just show you how to do the two things. Joins and another thing. So no joins. So
We add a field with the field calculator and then you tell it what the equation is and then it does it.
no. The zonal statistics. Yes.
Oh, yeah.
So first of all,
Confusion.
we need to do the zonal statistics. Okay, to compute the hazard in each building. Okay? Okay. So now we have the hazard. We are going to have some value called flooding rate. Okay. So now we have the flooding height, we have the sum of the population. What else do we need? So first step, zonal statistics to compute the hazard. And to obtain a new field called flood height. Next.
Vulnerability.
Sorry?
Vulnerability.
Vulnerability, okay. And how we can define the vulnerability?
You put the hazard and the exposure together.
No, that's not called the vulnerability.
Maybe the K?
We are using the field calculator. To create a new field called let's call it vulnerability percent.
I did.
Vulnerability factor, let's call it. And this vulnerability factor is for population 1 or 0. 1 if flooding height is higher or equal than lower than. So we said last week, for vulnerability for population we don't have a function but a threshold. If you have more than, what do you want to set? 20 centimeters, 30 centimeters, half a meter. If you have more than the threshold, you are affected. If not, you are not affected. So now we have this new field, This is used to obtain the vulnerability function. And now the hazard goes into the vulnerability. So our last step is to field calculator, new field called consequences over population, and it is exposure, which is sum of times vulnerability. Do we all agree? Yes.
Yes.
So
And then you make sure that.
I'm going to keep it here. Don't worry. So
He did. But you can kind of whatever you want.
4, could you get 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So it's being born
Oh, yeah, it's fine.
20, 20, 100, 20, 20, 500,
I'm gonna do it the other way.
20, 50, 100, 20,
Whatever you want, but not, that won't be the error. That's just-
20 to 100,
It's just a new-
100 to 100, 500 to 100, 50 to 100.
That's the first one. Hazard.
we have a lot of information to deal with.
Oh, okay.
There are a lot of raster files. So this is my desk, this is the screen, and these are your sheets. Okay? So please, you are going to do the 2020 100, the 2020 500, the 2050 100, the 2050 500, so on. Okay? Try to do this and obtain the consequences on population.
One of the statistics is giving an error that says that one of the data fields is not.
Let me try to do that, and we will see if we have any error that could be. So, zonal statistics, exposure data, raster layer, this one, prefix graph 8. I'm going not to compute the count, neither the sum but the mean, and exposure data. Yes, so if you obtain an error, you go to advanced algorithm settings and skip ignore. Okay?
Oh, well, I can do this right away. Yeah.
And you run.
So it's like your-
You close and you take
That's fine.
yeah. I repeat, okay? Once you go to the zonal statistics to compute your Fahrenheit, go for advanced algorithm settings and don't stop but skip. Okay? Okay. So I'm going to prepare here a table